In today's session that we're going to learn sum and the difference of formulas. Sum and the difference of formulas. Okay. There should be like a three sets of it, sum and the difference. So we're going to learn sine alpha plus or minus beta, which is sine alpha cosine beta plus or minus. Well, this plus corresponding to this plus, and this minus corresponding to this minus. So cosine alpha, sine beta. Okay, so that's the first one. And the second set is a cosine alpha plus or minus beta. That would be cosine alpha, cosine beta, minus or plus. So you can see the corresponding relationship here. Here's a plus, then here's a minus. All right, and then sine alpha, sine beta. All right, and then the last set is a tangent alpha plus minus beta. That will be, the top will be tangent alpha plus minus tangent beta over the denominator is 1 minus or plus, just opposite, tangent alpha, tangent beta. It depends on your teacher's requirement, because some of the teachers would ask you to memorize these formulas. That's what I did when I was in high school. I do remember my teacher asked us to memorize this, but you're not really required for some school, and the teacher will either give it to you, they allow you to bring this as the cheat sheet. And in the last part of after today's session, at the end of this video, I'm going to show the proof how to get this formula. It's a little complicated, but I know some schools are not require this, do not require this. All right, now why we need this? Why we need this alpha plus beta, alpha minus beta, those type of things. One reason is it gives us more freedom to find the sine and cosine or tangent value for certain degrees, certain values, certain measurement of the angle. And for example, we are very familiar with the 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. And also everything related to that. We're 100 familiar with this. I assume that you already know this. You know all the sine value, tangent value, sine, cosine, tangent value of all those of these angles. However, if I ask you this question, for example, if I ask you, can you find me the exact value of sine 75 degree? Can you do that? We don't know how to do that. You can use the calculator. You can plug in the calculator to use that to find the sine value, the value of the sine 75 degree. But the number you get is not the exact, because it's not the exact value, because you're going to see after the decimal point there's unlimited number of digits there. So how do you find that? However, if we look at all the angles we're very familiar with, we notice that a 75 is 30 plus 45. Okay, so if you know this, then you can write that as sine 30 degree plus 45 degree. Then you can use the first formula, sine alpha plus beta, which is going to be sine 30 degree cosine 45 degree plus cosine 30 degree sine 45 degree. Now you can just find the exact value of each item and then simplify that so you can get the exact value for sine 75 degree. So you know sine 30 degrees is 1/2, and the cosine 45 degree is root 2 over 2 plus cosine 30 degree. Do you remember what is cosine 30 degree? It's root 3 over 2 and the sine 40 degree is again is root 2 over 2. Okay. If you're not 100% familiar with this, you can use this method. I don't know if you have, if a teacher ever told you this. So that's your thumb, and that's uh, your 5 fingers. All right. So this is like a 0 degree, 30 degree, 45 degree, 60 degree, and a 90 degree. Okay, the finger formula and the finger method. And for the sine of it is going to be 0 or root 0 over 2, and here will be root 1 over 2, which is 1/2. Here's root 2 over 2, here's root 3 over 2, and this is root 4 over 2, which is 1. So this is the way that if you are not 100% familiar with this, then you can just use this. Root 0, root 1, root 2, root 3, root 4 over 2. So that's your sine value. And the cosine will just be opposite. Okay, 0, 1, 2, 3, 4, and then take the square root of it and over 2. Okay, so this is something extra. I don't know whether you like to use this, but anyway, or if you can just memorize those values, that would be perfect. It's not a very beautiful hand. All right, so let's simplify this. This is root 2 over 4, and here is root 6 over 4. Or you can write that as, okay, denominator 4, and the numerator is root 2 plus root 6. So this is the exact value of sine 75 degree. Okay, and very similar, can you do sine 15 degree? Again, we don't know 15 degree is not in our comfort zone. So, but we know that you can use either 45 minus 30 or 60 minus 45. Let's do this. 60 minus 45. So that will be 60 degree we're very happy with, and a 45 degree we're also very happy with. Okay, so that sine alpha minus beta. Sine alpha minus beta would be sine alpha cosine beta minus cosine alpha sine beta. So that would be sine 60 degree cosine 45 degree minus cosine 60 degree sine 45 degree. Okay. So that is root 3 over 2 root 2 over 2 minus root 1 over 2, right? Or 1, just 1/2, okay? And root 2 over 2. So your answer will be 4 in the denominator, and the numerator is root 6 minus root 2. Okay, so that is the exact value of a sine 15 degree. So let me just give you one more. I ask you to find what is the cosine 165 degree. Again, 165 is not in our comfort zone, but a cosine 165, if you remember the unit circle. Okay, this is 165, right? And a cosine of that is this part. And it should be negative cosine 15 degree. Would you agree? This is 15 degrees here, right? Because they're just opposite side. So we can get that. Or you can use cosine as 120 plus 45. You can do that. Or you can use this as a 45 minus a 30 as this 15. So either way, you can use all different ways. See, you can find a lot more exact values of the angles. Okay, so let me just use this one. So that will be negative cosine alpha minus beta, cosine alpha minus beta. See, cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So this would be, I keep this negative sign outside. So I will get a cosine 45-degree cosine 30-degree plus sine 45-degree sine 30-degree. And that is negative. Okay, cosine 45 is root 2 over 2, and this is root 3 over 2, plus this is root 2 over 2, and the sine is root 1 or 1 over 2. So I have, because here's a negative, so I have a 2, and I have a negative root 6, and here is negative root 2. Okay, so that is the exact value of a cosine 165 degree. Now you say, well, can I prove this? Can I prove this alpha, whatever angle, 165 degree? And you just tell me that is, we take the supplement angle of that. So we get a 15 degree, and I get that. So which is this? I said cosine alpha or cosine pi minus alpha. Here is a 15 degree, which is a negative cosine alpha. Can you prove it? Can you verify that? Can you verify this? Well, yeah, because this is the difference, right? And once it has a difference, the cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So which is, so the left side is cosine alpha minus beta, angle minus another angle. So I get a cosine pi cosine alpha plus sine pi sine alpha. You agree? Then you know sine pi, that's 0. And the cosine pi, that's negative 1. So that will be just negative cosine alpha. So we not only can just simplify, use a graph to show the relationship, and then we proved that using the sum and the difference formulas. It sounds really cool, isn't it? Okay, so since we're here, let me ask you to verify the next. Verify, okay, I will ask you to verify this. Cosine alpha minus beta over sine alpha cosine beta equals cotangent alpha plus tangent beta. So let's start from the left side. Now you're familiar with the cosine alpha minus beta, right? That would be cosine alpha cosine beta plus sine alpha sine beta over sine alpha cosine beta. Okay, since you know A plus B over C will be just A over C plus B over C, right? We can write that separately. So I get a cosine alpha cosine beta divided by sine alpha cosine beta. And the other part, sine alpha sine beta equals sine alpha cosine beta. And then I'm going to use my pencil to cross out the common factors. So cosine alpha over sine alpha, which is cotangent alpha, and the sine alpha over cosine beta, sine beta over cosine beta is tangent beta, which is the right side. So I verified this. Okay. See, I'm using this difference formula. The difference formula. All right. So let me ask you another question. Hold on, let me get a piece of paper. I need more paper. All right. I would ask you to give me this information. Okay. I have two angles. I have alpha. Alpha is a in quadrant 2 angle, and I know sine alpha is 5 over 13. And I also have a beta. Beta is in quadrant 1, and I know sine beta is 3/5. Okay, and I'm asking you the following. I ask you four things. A, can you find a cosine alpha? B, can you find a cosine beta? C, can you find sine alpha minus beta? D, can you find a sine, let me do cosine alpha plus beta? So let me ask you these four questions, okay? So if you have alpha in the quadrant 2, the reason I give you the quadrant 1 and 2 is to help you to identify the sign of its sine and cosine. Because for the quadrant 2, we're going to get a positive sign, but our cosine is going to be negative. So my cosine alpha is going to be negative, okay? And for the quadrant 1, the cosine beta is going to be positive. That's what I know, right? All right, now for cosine alpha, okay, since we know sine square alpha plus cosine square alpha equals 1. Do you still remember where do we have that? The magic hexagon, right? Okay, so we know sine is 5 over 13, so it's a 5 over 13 square plus cosine square alpha equals 1, which is 25 over 169 plus cosine square alpha equals 1. So my cosine square alpha is 144 over 169. And cosine alpha, remember I have to take the negative sign. So it's going to be negative square root of 144 over 169, or negative 12 over 13. Okay, so I got that. And the B is going to be very similar because I'm looking for cosine beta, and I know cosine beta is going to be positive. I know sine. So sine square beta plus cosine square beta equals 1. And the sine square beta is 3 over 5 square plus cosine square beta equals 1. So 9 over 25 plus cosine square beta equals 1. So my cosine square beta, I subtracted this, so it's going to be 1 minus 9 over 25 is 16 over 25. But my cosine beta, I'm going to take a positive square root of that, 16 over 25, so it's a 4 over 5. Okay, so I get my answer. I get a cosine alpha, cosine beta. Let me just write it here, okay, make it a little easier. Sine alpha by given is 5 over 13. My cosine alpha is negative 12 over 13. And my sine beta given is 3 over 5. And my cosine beta is 4 over 5. I keep this. I write it somewhere, make it a little easier, because next I need to find sine alpha minus beta. So my C, sine alpha minus beta. By the formula, sine alpha minus beta should be sine alpha cosine beta minus cosine alpha sine beta. The good thing is we know all of them here, so I just go substitute. So it's going to be 5 over 13, and cosine beta is 4 over 5. Subtract. Cosine alpha is negative 12 over 13. Okay. Let me just write negative 12 over 13. And then multiply by sine beta. Sine beta is 3 over 5. All right. So I get The denominator 5 times 13 is 65. The top is 20. Then here is a minus, then here's a minus, so I go plus, and then multiply, I get a 36. So my answer is 56 over 65. That is the exact value of my sine alpha minus beta. And the last one, I need to find a cosine alpha plus beta. So let me see. I need to do cosine alpha plus beta. And a cosine alpha plus beta cosine should be cosine alpha cosine beta minus sine alpha sine beta. So that's going to be cosine alpha cosine beta minus sine alpha sine beta. And then we just substitute cosine alpha is negative 12 over 13. Cosine beta is 4 over 5 minus sine alpha is 5 over 13. Sine beta is 3 over 13. Okay, so the denominator is 65, and the numerator here is a negative 48, and negative 3 by 5 is 15, and that would be negative 63 over 65. That is the cosine alpha plus beta. All right, so I think we kind of get that, and let me maybe just do one more. I ask you to verify this because we haven't do tangent yet. So verify x plus pi, tangent x plus pi is the same as tangent x. All right, now if you just look at the graph, okay, and if that's your x, and the tangent of x is just the slope of this line, and then tangent x plus pi, it goes to here. Okay, so they share the same slope. So we know the tangent value is the same. But let's just use a formula to prove that it equals to this. And keep in mind that we have the tangent formula here. Tangent alpha plus beta, which is tangent alpha here is a plus tangent beta, and here's 1 minus tangent alpha times tangent beta. So that, let me just write it here. Tangent alpha plus beta is tangent alpha plus tangent beta. And here it would be 1 minus tangent alpha tangent beta. This is the formula. And in our case, my alpha is x, my beta is pi. So the left side equal to tangent x plus tangent pi, 1 minus tangent x tangent pi. And what is tangent pi? Tangent pi is 0. We know that. So therefore, the top is tangent x plus 0, and bottom is 1 minus tangent x multiplied by 0. And that is 0 is gone. 1 minus 0 is just 1, so the answer will be just tangent x. That's the right side. And we verified. Okay, so we proved that tangent x plus pi equals tangent x. This section, basically, we just talked about all those plus minus, or we call that a sum and a difference of formulas. Okay, so I don't know if you can memorize that. If you don't, then that is fine. You can put that on the cheat sheet. And the good thing is it gives us more freedom to find the exact value of this angles, and also it can help us once you are given like this one. If you're given something about alpha, something about a beta, then you can deal with alpha plus beta and alpha minus beta. So that's this section, sum and the difference of formulas.